So today we will be doing a case study on inheritance where we will be having more than one classes in a hierarchy, and we will be calling different functions either from the base class or from the derived class, and we will try to show an example where we have multiple inheritance as well. Like for example, if we have a base class and there is another class which says okay, this is my base class, and this is yet another class which says this blue class is my base class. Okay, now this is a multi-level inheritance, as I have already told you, but there can be multiple inheritance as well. For example, if we have two different classes, they have no relationship with each other, and we have a child class, and the child class says that okay, this class is my parent class and this class is also my parent class. So this is multiple inheritance. This is multi-level inheritance, and this one is multiple inheritance, right? So we will be trying to see an example of this as well. For example, in this particular case study, we will be having a class named employee class, and this employee class will have a child class that will be salaried class, and we will be having another independent class which will be a student class. It won't have any parent, but we will have a graduate assistant class which will have two parent classes. One will be the student class and the other will be the salaried class. So, right. In multiple inheritance, we have more than one base classes. It's not just restricted to two base classes. Like here we have two base classes. Maybe there is a third base class, let's say human, right? So it can have 3 or 4. One class can have 5, 6, any number of base classes it may have. So it is multiple inheritance. This may multiple inheritance may cause naming conflicts, right? There are other names for this conflict as well, but the most common conflict is known as the naming conflict. We will be seeing this naming conflict in the case study which we are going to do shortly, but before going to the code, let me explicitly state it here. For example, we have this base class, and this base class has function, let's say a function d, right? We have another base class, and this base class also has a function d, right? And we have a child class. This child class says that okay, this is my base class and this one is also my base class, right? And this child class calls the function d, and this d function is not available with this child class. Now what will happen? The compiler will first of all search this d function within this child class, but obviously it will not get it. Then actually it goes to each and every parent class of this child class to search for this particular function, right? In this case, it will find this d function here in one of the parent and in another parent as well. Now this is what makes a naming conflict to occur, right? So in such case where if you call a function in child class and this function is available in more than one classes, right? Here we have two classes, but we could have 3 or 4 classes as well. And if this function was available in more than one classes, then it will result in the naming conflict, and the compiler will simply produce an error because it would not know that which one should it be calling. Okay, you may let me demonstrate it in a different way. For example, here we have this hierarchy of classes, and we want and this student function, let's say this function has let's say a function named display, right? This, okay, and we have an employee. The employee class also has a function name display, right? And this salaried class has some other functions. This graduate student has got some other function, but in this graduate student class we call the function display. We call it, we do not have it here in the graduate student class, but we simply are calling this function. Now what will happen, it will search for this graduate student, for this display function in this graduate student class. It will not find it, then it has multiple parents. It will get it from this place, okay, right, from one parent. From the other parent it will go to its immediate parent, but in this hierarchy the salaried class has do not have this display function, so it is not going to stop here. It is going to go to its grandparent, right, and it will find the display function there, right. So in this case as well, the naming conflict occurs, and the compiler has to decide either to call this function or to call this function, right. So in this particular case it will cause an error, right. So this naming conflict needs to be resolved. Although you may be thinking that okay, this student class display function was found first and it was in the immediate parent, and this employee class display function, although it is found, but it is found later and it is not available in the immediate parent, but so maybe the one which is nearer to the graduate student class should be called, but it's not the way it will be working. It will try to find this display function in each and every hierarchy towards the parents it has. For example, if it has another class, let's say again human, and it was searching for display function in this hierarchy of the student parent, and it was searching the display function in this hierarchy as well, in the salad. And in this particular case, if we have a third hierarchy for the graduate student class, it would search for the display function here as well. But in this particular case, this parent does not have this display function, so it is not going to return anything. But since the multiple display functions will be found, so it will result in a naming conflict. Okay, so this is what naming conflict is. So let me try to explain it to you via an example here. Here we have a class, base class 1. This base class has a public function fun base 1, right. We have another base class, base class 2, and it has another function fun base 2, right. Now here if you see, we are doing multiple inheritance. We have a class named derived colon public. I hope now you understand what this public type of inheritance means. By public type of inheritance, every public member of the base class will become public member of the derived class. Every protected member of the base class will become protected member of the derived class, and every private member of the base class will yes, bilkul. It will not be received in the derived class, because in inheritance we only inherit non-private members, right. So private members we are not dealing here. So we have made two base classes, public base 1 comma public base 2. So this class has two base classes. Now this derived class has its own function fun derived, and that's all. And if you see in the main, we have made an instance of the derived class derive, and we are saying derive.fun1. Now what will happen, it will go to this own class and it will try to search for this fun base 1, and it will not be able to find this fun base 1 function. Now what will it do, it will go to its first parent and try to find it there, right, and it will find this fun base function here. It will also go to its second parent, right, and the fun base 1 function is not available here, So there is no naming conflict. So it will simply call the the fun base one function from the base class 1, right? Now in case of this line, through the derived class instance, we are calling the fun base 2 function, right? So it will first of all go to the derived class, and here it will try to find the base 2 function. It is not available here. So it will then go to the base class 1. It will try to search for a base 1 function. It is not available here as well. It is not available here. Then it will go to the second parent, and here it will find the fun base 2 and it will simply call this function, right? And again in this case there was no naming conflict again. And in the third case we are calling the fun derived function through the instance of the derived class. So first of all it will go to the derived class and it will try to search for the fun derived function which is available here. So it will be simply calling this function. So in this particular example there was no naming conflict, right? So now let us go to another example here. Okay, this is a bit bigger example. So here we have okay, we have this line. I should explain this first to you. Type def unsigned long ulong. So I hope I have previously explained to you what type def does, but I think it requires a bit of explanation here. So let me okay, oh sorry, let me explain it to you, right? For example, you say that int x, you have declared this variable, right? So this is a standard way to declare variable, right? But if you feel like, okay, I want to change this int, right? Next time I do not want to use the word int to declare an integer. I want to use a different word. Let's say I want to use the word let's say Tony, for example. Okay, now what you can do, you can simply write type def, right? This is the keyword, okay, and after this you will be writing the name of the data type which you want to rename. I want to rename int, right? And this is the old name of this data type, and its new name is Tony, right? Semicolon. That's all. Now in the following lines I can declare int y which is equal to, let's say, 3, which will work. But instead of using int I can say Tony z is equal to 33. Now here this Tony will represent what? If you see, this Tony is going to represent this int. I am simply replacing the word int with Tony, but I can still use the keyword int or data type int. So this is how type def works. So you can give a new name to any other data type. For example, you say type def double and int d, you call it like this, okay? So int double or something like that. So you can simply give new names to a data type. So same goes here. If you see here, this unsigned long has been given a shortened name which is ulong. So this is for convenience only. Otherwise you can use unsigned long in the remaining code, and we will see it has been used interchangeably, but since this line was there, so I felt it to explain it to you. Now here in this example we have a class, student class. In this class has two variables. One is id, which is of ulong type, and we know that ulong is unsigned long, right? And another variable is age, which is having the data type unsigned, right? So and this student class has 4 functions. The first function is the get age function, which simply returns the value of the age. It is constant, so this function is a const function, and I have already told you that in classes we have functions which are const, and any const function cannot change the value of the member variable of the class. It can simply return it, it can see out it, but it cannot change it. So this is what this is the restriction on the const member functions, right? Then okay, we have another function get id. Get id simply returns the id of this class, the id variables of this class. Then we have set function, set age and get age. The set age receives a variable named n, and it assigns this n to this age variable, and set id receives this variable n and assigns this n to the data member id, right? So this first class is the student class. Now we have another class which is the employee class, and if we see, the employee class also has 2 variables, age and id, right? And if you see, the member functions of the employee class are also same. It has get age, set age functions, set id, get id functions, which were also available in the student class as well. Okay, so these two are independent class, they do not have any relationship between them, neither of them is a parent of each other. So these are 2 classes. Now we have another class which is called the salaried class, right? And this class says that employee class is my parent class, right? So whatever is in the employee class which is non-private, right? Let's see in the employee class what is non-private. Oh, if you see here, we have private variables age and id. It means that these age and id will not be available in the salaried class, right? Okay, and but if you see in the employee class, these get age, set age, get id, set id, these functions are public. So these functions will be available to the salaried class, but the private variables will not be available to this child. So this salaried class has its own 2 functions, which is set salary and get salary and set salary, which simply assigns and returns value of this salary variable. So in total, this salaried class has 2 functions of its own, but it receives these 4 functions from its base class because they are public, right? And it is not receiving any variable from the base class because the variables are private. If these were protected, they would have been available in the child class, right? Now we have the okay, so far we have 3 classes, right? We have a student class, we have an employee class, right? And we have a class that is named as salary, and this salary class says that this employee class is my parent. So far we have created these 3 classes. Now let us go to the 4th class, which is the graduate assistant class. And this graduate assistant class says that I have two parent classes or two base classes. The first base class is the student class and the other base class is the salaried class, right? And the type of inheritance here is public, right? Usually most of the time it's public, but you can use private and protected as well. If I remembered, I will be telling in the towards the end of this lecture the significance of public and private and protected type of inheritance. You already know about the their effect on the inheritance, but there is some significance of using private type of inheritance as well. So in any case, coming back to what I was saying, here we have a graduate assistant class having two parent classes, and let's see what are we going to have in this graduate assistant class from the base class student and salaried, right? So first of all, let's go to the student class, and if we see here these two variables, although they are declared, but there is no mention of the access specifier, right? So by default everything is private. So by default these variables are private, so they are not going to be inherited in the child class. But these four functions, they are public, so they can be received in the child class. Similarly, in the employee class, here explicitly private has been mentioned, so these are not going to be accessible or inherited in the child class. And these four functions, since they are public, they are going to be inherited in the child class, right? So this is how it works. And if you see here, you have we have simply called sorry, my mistake. I've directly gone to the definition. I've missed this declaration of the function. In the graduate assistant class, we have no member variable, but we have defined a function display, right? And this is defined outside the body of the class. And here we are simply calling four functions. First function is get id, the second function is get salary, and the third function is get age, right? So remember, we have get id, get age, set id, set age, like setters of id and getters of id are both available in student and employee class. Now if I summarize this here, we have a class student, we have a class employee, we have a class salary, and this salary says that I have one parent which is employee, and we have another class graduate assistant, and we say graduate assistant, right? And the graduate assistant class says that I have two parents, student and employee, right? And in the student we have variable id and age. These both are available here. And in the employee, variable id and age. These both are again available in the employee class. Both are available here, right? And setters and getters are also available. Now in the graduate student class, here we have called the function get id, right? And if you see, first of all, compiler will go to the class itself, it will try to search it here, get id function, it is not going to find it, right? Then what will happen, it will go to the first base class, which is the student base class, and if you see, we have the get id function here, it will receive this get id function here, from here. Then it will go to the second base class, which is the salaried base class, right? In the salaried base class, there is no function named get id. But again, this salaried base class, okay, I have done a mistake here. Let me fix that first. This graduate student, it's not like this, it's like this. The graduate student says that salary is my base class, and salary says my employee is my base class, right? So it will first go to the salary class, and it will try to find the id function. It is not here. Then it will go to its grandparent, and there it will find the get id function, which will be available there. So here, keeping ourselves here, at this place we will have two get id functions, right? and here again we will have two get age functions, right? One from the student class, one from the student class, and other from the employee class. So this results in an ambiguity, and this code is going to produce errors. So this was an example of how this naming conflicts, you can call it naming conflict, you can call it ambiguity, this occurs. And mind it, here we have demonstrated the naming conflict or ambiguity using functions. This can also occur by using variables as well. For example, a class has 2 or 3 parents and we want to access a variable, but this variable is not available in the class, then okay, we will go to the parent classes, and that variable with the same name is available with multiple base classes. So in that case the ambiguity will occur as well. So this was an example of ambiguity. Now let us think about the exclamation mark, let us think about the solution. So what could be the solution to this? Think. Okay, the solution to this, there are two solutions to this. One is called virtual inheritance. This is a complete topic which we'll be covering in the next lecture, and it's a detailed topic. For present, the solution is the direct solution, where instead of calling a function, we also write the base class name as well. Okay, give me the get age function from the student class and give me the get age function from the, let's say, cell date class. So in this particular case, the compiler is not going to go to every base class searching for the set age function. It is directly going, it will directly go to the class where whose name is mentioned before the scope resolution operator. So this thing resolves the ambiguity. So here what we could have done, we could have simply written here student scope resolution operator. So this will resolve the ambiguity problem and it will not occur. For example, here we say get it from employee, for example. So here the ambiguity issue will be resolved using a direct mention of the base class from which we want to call the function. So this is again the same example, the same code. I don't need to re-explain everything. So only difference is here that here explicitly the name of the class is mentioned from which we want to get receive the function get id, right? So this resolves the issue of ambiguity, right? So this is how it happens. You can also do it in the main as well. So now the program will compile successfully, right? I hope it is clear to you. In the next lecture we will be talking about virtual inheritance.